This is Jeffrey Friedland. Welcome to another edition of Insider Talks at Emerging Technology Insider. Today, I'm delighted to have with me Joel Shertok, who is joining us from Delaware. Joel has a PhD in chemical engineering from Princeton. Welcome, Joel.
Hi, Jeff. Happy to be here.
Joel has agreed to spend a few minutes with us to discuss process commercialization in a post-COVID world. That's sort of a mouthful, Joel, but let's get started with basics. What exactly is process commercialization?
Well, process commercialization is a process wherein you take a small scale process that one does in glassware and scale it up to first pilot plant and then into commercial production. So typically, a chemist will come up with a process. It's in beakers, it's in retorts, and chemists can make 10, 15 grams at a shot. And goes to a customer says, this is the best stuff I've ever seen, but I need a drum to evaluate my process. And the chemist is thinking, well, that's about 2,000 beakers. That's a little more than I can do. So what you do is you come to me as a chemical engineer, and I'll take that glassware process and put it into a pilot plant with real chemical equipment, reactors and vacuum, and make a drum, 400 pounds. And if that is effective, you then take it into a commercial plant where you start making tons. And that, in essence, is what commercialization and scale-up is.
Okay, so it's actually somewhat simple when you listen to you explain it that way.
It's a simple concept. The deal is in the details, like everything else.
Right. Joel, you have a very extensive background in this process commercialization. Can you tell us about some of the projects you've worked on, including some of what you view as perhaps the most exciting or high-profile involvements you've had over the years?
Well, I've got two that I think are really interesting because it shows how commercialization can be very, very trickful if you're not careful. We were doing a government project, and we're making a diene, basically an epoxy, that the government was going to use in some sort of nuclear research. I didn't have a clearance, so I didn't know, and frankly, I didn't care. So the chemists came up with a glassware process, very, very nice, and it simulated what the commercial process would look like. But because of cost considerations, it was only operated between 8 o'clock in the morning and 5 o'clock in the afternoon. Shut down, start the next day. It was great. Government liked the stuff, we liked the stuff, built a commercial plant based upon the process, and we started up. And it worked absolutely fine for the first week. Week 2, it began to produce a yellow polymer that nobody wanted. It was a contaminant. And what happened was it built up over a period of time, and operating the unit in the lab for only 8 hours at a shot, it wasn't long enough to see that. So massive panic, as there always is, went back into the lab, this time operated it for a day and figured out what the problem was and solved it. But because it was a government project, a high profile, nobody wanted problems like that. But again, you don't panic and everything is fine. The second one is a commercial product. We made a material called caprolactone, and it's used in the automobile industry to make coatings. Because of the process we used, the coating turned a beautiful color of Kelly green. I mean, you couldn't duplicate that if you wanted to. It cost you a fortune. But it's supposed to go into a clear coat, and the customer was not happy about having a green tint. But we convinced him that this is part of caprolactone chemistry, and he bought the line. Then the Japanese came in and said, wait a second, we've got a caprolactone that's clear. And by God, they did. And the customer said, you've got like 2 weeks to clear this problem up or you're out. And it was a big customer. So what happens when it happens? Massive panic, and went out saying, Shertok, solve it, solve it, solve it, solve it. And it was a very interesting project because it turned out the color body was less than 1 ppm of the whole thing. Tiny, absolutely tiny. It was made in the reaction step, which nobody realized. So we had to beat on the reaction step for about 2-3 weeks, and we got rid of the color body, and everybody was happy. We saved the business, and it was very, very satisfying. We had a whole team of people down in one of our plants for 2 weeks straight. Great success. And that's what commercialization is all about.
Oh, okay. Joel, COVID-19 and the pandemic has just affected everybody and everything. What, from where you sit, has been the impact on process commercialization as a result of COVID-19? And, what do you see happening today? Is it better than 6 months or 9 months ago?
Well, basically, it's been a disaster. I work with a lot of startups, and a lot of these startups work in labs. I mean, that's how you begin to scale up. Many people are locked out of their labs. I've been dealing with colleges, Stony Brook, Queens College, and a part of CCNY, and basically they have been locked out for the last 6 months to a year, which means they couldn't do any work, which means commercialization came to an absolute halt. Even worse, people who were in the same lab had to relocate. One group I'm dealing with was with CCNY. One contributor had to go back to Austin, Texas. One contributor went to Brooklyn. And it's very hard to do collaborative work when you're separated by a couple of thousand miles. So it's really slowed things down. In chemical plants, not so much, because these are essential workers. You cannot shut down a chemical plant. So the operators worked, and they work with masks, and they hope for the best, and that's what happened. But the raw material for commercialization, which is lab studies, it just came to a halt. And it's only first now, slowly beginning to get back to something normal. To get into Queens College, it was almost like going through Checkpoint Charlie during the Cold War. You needed passes and permissions and slips and slips and slips. It was impossible.
Okay. That's interesting. Joel, no one can really, tell us what the post-COVID world will look like and how business practices will change. We're seeing it, now as we're starting to come out of COVID a bit, how quickly things are somewhat coming back to a status quo. But based on your experience, as we come out of the pandemic, what impact do you see on process commercialization as likely? Where do you see things are headed?
Well, the thing about commercialization is you can't do it via Zoom. I mean, you can be an office worker and Zoom in and everything is fine. But if you're doing commercialization development, you've got to be in a lab, and you've got to be in a chemical plant. So there has to be a reasonable degree of confidence that you're not going to get sick. And psychologically, that means you've got to get vaccinated. Fortunately, as I see it, the people who are most likely to be vaccinated are technical workers. Certainly the guys in the lab are not going to have the same COVID hesitancy as somebody who doesn't have a technical training. So I'm very hopeful that with the level of vaccination that we see today, we will be able to get back to normal as far as chemical industry is concerned, probably in 2 or 3 months. I suspect that once the new semester starts in September, barring the emergence of a new strain that's more virulent, it will be business as usual. Everybody wants to get back. This is not benefiting anybody to be sitting at home twiddling your thumbs. There's money to be made. There's all these incubator contests that have to participate to raise money. If you're sitting in a lab and can't do your work, you're in serious trouble.
Okay, let me come back to one other thing. You're doing consulting work right now, right?
That's correct.
Okay, can you just, you don't have to name names, but can you just sort of generically, Joel, tell us about some of the companies you're involved with, or types of projects, or what your niche is as a results, as it relates to the kind of companies that you can be beneficial for?
So I'm working, the good thing about being in my niche is you get a wide variety of projects. I tend to deal with startups, which is a really interesting niche to be in. So I'm working with one company right now is creating a novel ion exchange membrane to generate hydrogen as part of the green economy. They have a laboratory process, which is great, but they're under incredible pressure to make more material, because the more material you make, the more money you make. So I've been asked to come in and say, hey, look at our process. How can we commercialize this? Can we make it continuous instead of batch? And look at our safety. Obviously, if you're in a plant, safety is paramount these days in the chemical industry. Look at our safety and generate a safety program for us. So that's kind of typical. Another company has a very novel microbe that loves to eat contaminants in brownfield sites. And of course, Delaware has a lot of old DuPont buildings. Right. Rochester has a lot of old Kodak buildings. This bug loves to eat pollutants. So you mix it with mix the bug with contaminated soil, heat it, and 2 days later it's all gone. So a fantastic way of converting brownfield to greenfield with minimum effort. Also, there's a lot of work these days with PFAS, basically part of the old, the Teflon supply chain. This bug likes PFAS too. So wonderful methodology for eating it up and making, getting out of water, getting out of soil, but infinite possibilities.
That's really interesting. Okay, Joel, are there any last thoughts you'd like to leave us with today?
Well, I would like to submit that doing commercialization is the heart of chemical engineering. I mean, working with a process that you're just debugging is okay, but when you're starting with a process that is first being conceived and first being created, there's so much potential to get in there and make a really interesting process, save the money up front, do the right things without making all the heartache of trying to correct something that's already an establishment. And it's fun. My phone rings. I never know what I'm going to be hearing about the next day. So if you got to make a living, this is not a bad way of making a living.
Well, that's great. That's great. Joel, thanks for spending a few minutes with us here today at Emerging Technology Insider. We'll probably have you back and, sort of an update as we continue to come out of this COVID pandemic mess. To you, our viewers, thanks for joining us here again today at Emerging Technology Insider for this Insider Talk segment with Joel. Until next time, goodbye.
Goodbye.